Why is Math.Floor, x, y, not equal x4/4/y for two evenly divisible floats in Python? I have been reading about division and integer division in Python and the differences between division in Python 2 vs Python 3. For the most part it all makes sense. Python 2 uses integer division only when both values are integers. Python 3 always performs true division. Python 2.2 Plus introduced the // operator for integer division. Examples other programmers have offered work out nice and neat, such as: how is // implemented? Why does the following happen? Shouldn't x4/4/y equals Math.Floor, x, y? These results were produced on Python 2.7, but since x and y are both floats, the results should be the same on Python 3 Plus. If there is some floating point error where x, y is actually 4.9999999999999 and Math.Floor for .9999999999999 equals 4.0, wouldn't that be reflected in x, y? The following similar cases, however, aren't affected.
That's because .1 cannot be precisely represented in binary. You can also see that
the issue is that Python will round the output as described here. Since 0.1 cannot be represented exactly in binary, the result is something like 4.99999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999.
I didn't find the other answer satisfying. Sure, one has no finite binary expansion, so our hunch is that representation error is the culprit. But that hunch alone doesn't really explain why Math.Floor 5/1 yields 5.0 while 5/1 yields 4.0. The punchline is that A//B is actually doing floor, A%B/B, as opposed to simply floor, A/B. 0.5/0.1 is exactly 5.0. First of all, note that the result of .5/1 is exactly 5.0 in Python. This is the case even though 1 cannot be exactly represented. Take this code, for instance. And the corresponding output. This shows that 5 can be represented with a finite binary expansion, but 1 cannot. But it also shows that despite this, the result of .5/1 is exactly 5.0. This is because floating point division results in the loss of precision, and the amount by which den differs from 1 is lost in the process. That's why Math.Floor 5/1 works as you might expect, since 5/1 is 5.0. Writing Math.Floor 5/1 is just the same as writing Math.Floor 5.0. So why doesn't 5/1 result in 5? One might assume that 5/1 is shorthand for floor 5/1, but this is not the case. As it turns out, the semantics differ. This is even though the PEP says floor division will be implemented in all the Python numeric types and will have the semantics of. As it turns out, the semantics of 5/1 are actually equivalent to, where mod is the floating point remainder of .5/1 rounded towards 0. This is made clear by reading the Python source code. This is where the fact that 1 can't be exactly represented by binary expansion causes the problem. The floating point remainder of .5/1 is not 0. And it makes sense that it isn't, since the binary expansion of 1 is ever so slightly greater than the actual decimal 1, the largest integer alpha, such that alpha asterisk 1 is lower than or equal to .5 in our finite precision math is alpha equals 4. So mod.5.1 is non-zero and is roughly .1. Hence floor.5 mod.5.1 slash .1 becomes floor.5.1 slash .1 becomes floor.4 slash .1 which equals 4. And that's why .5 / 1 equals 4. Why does / do that? The behavior of A / B may seem strange, but there's a reason for its divergence from Math.Floor A/B. In his blog on the history of Python, Guido writes, the integer division operation, / and its sibling, the modulo operation, %, go together and satisfy a nice mathematical relationship. All variables are integers, such that, assuming A and B are equals 0. Now, Guido assumes that all variables are integers, but that relationship will still hold if A and B are floats, if Q equals A / B. If Q equals Math.Floor A/B, the relationship won't hold in general. And so / might be preferred because it satisfies this nice mathematical relationship.
If you want to support the channel, please consider liking and subscribing.